This is a brief demo of an encryption program that I wanted to share with the Bitcoin Cash developer community. What this program does is it allows you to encrypt a message using a Bitcoin Cash address, using someone else's Bitcoin Cash address. Encrypt it, upload the message to the Bitcoin Cash blockchain, and then that person can use the same private key associated with that address to decrypt the message. And this has a lot of really important implications, especially when it comes to censorship resistance. In the same way that Bitcoin Cash is censorship-resistant money, it can also be an end-to-end encrypted, censorship-resistant communication medium. So, like, let's say you're in a despotic government situation like Turkey or Iran or China, and they don't want you to get a piece of message to someone else in the world. If you know that person's Bitcoin Cash address, such as you can get their address from like member.cash or memo.cash. This is member.cash, and if you go to memo.cash, these are social media websites that run on top of the Bitcoin Cash blockchain. So, like, for instance, Naomi Brockwell, if I wanted to send a message to her, I could find her Bitcoin Cash address right here, and I could encrypt a message with her Bitcoin Cash public address, and only she would be able to decrypt it with the private key that controls this address, the same one that she uses to post messages to memo.cash. So I've been working on this for a couple days now, and I probably need to put it on the shelf. And so I wanted to shoot this video to sort of capture the current state of the app so that other people can start playing with it. I do hope to make it better, but I want to capture the state that it's in right now. So the way I started putting this together is a command line application. So I'm going to show you a bunch of, there's no graphical user interface right now, it's just a couple, like 3 commands and then a bunch of code. So if you want to check it out for yourself, it's in my personal GitHub repository. So github.com/Chris Troutner/BCH-encrypt. That's what I'm calling this, BCH-encrypt. It's also on NPM if you want to look it up there, but probably the source code is the best. This is a Node.js JavaScript application. I'm using the Oakcliff template. I don't know if I have, but anyways, Oakcliff is the sort of boilerplate that I started with for making the command line application. And there's 3 commands. There's get key, which gets a person's public key from their Bitcoin Cash address. There's the send, which encrypts a message and writes it in chunks to the Bitcoin Cash blockchain, which you can then view with member.cash, and this is what it looks like. Here's an encrypted message, and then it's got a title that's auto-generated. And then there's a decrypt command. So I'm going to go through each of these 3 commands and give a demo on how to get someone's public key, encrypt a message, write that message to the blockchain, and then decrypt the message. So let's start with this get key command. So the best way to explain this is to look at mastering Bitcoin Cash. So if you go to fullstack.cash and go to the documentation page, you scroll down on fullstack.cash, there will be a button to take you to this documentation page. There will be a link to this Mastering Bitcoin Cash book, which is on bitcoin.com, developer.bitcoin.com. And I am in chapter 3, where it talks about keys, addresses, and wallets. And so this is the sort of a fundamental idea behind public key encryption and how it's used in Bitcoin, where you start with a private key, which is just a number, and then you use elliptic curve multiplication to generate a public key, and then you use a hashing function to generate a Bitcoin Cash address. And it's a one-way thing. So if you have someone's Bitcoin Cash address, you can't necessarily find out their public key. and if you have their public key, you can't necessarily find out their private key. So one way of getting someone's public key, if all you know is their Bitcoin Cash address, is you can look at the transactions on the blockchain. So that's what this get key command does. Is at the top. So I'm switching to the code now. At the top of the code for the commands. So this is the get key code for the get key command. I have an example of how to run this first example. Let's just clear the screen. That's not what I wanted. So I'm running the get key command, and it only takes one argument, which is a Bitcoin Cash address. And what it's going to do is it's going to use the infrastructure at fullstack.cash to go out to the blockchain, query all the transactions associated with this address, and then it's going to look through each transaction until it finds the public key, which is embedded in the output of a transaction. So here's the public key right here. It's just a, it's in hexadecimal format. But basically, I don't want to spend much more time on this, but basically I just want to emphasize that a Bitcoin Cash address is not a public key. And a Bitcoin Cash address is derived from a public key, and you can use this command to find someone's public key by searching the blockchain, but it only works if they have made a transaction with that Bitcoin Cash address. So anyways, that's how the get key command works. That's how you can look up someone's public key. Now let's get to the interesting one, which is encrypting and sending a message. So here's the code for the send command. And again, at the top I have an example. So we're going to encode the message test. Actually, let's just make it a little more creative. My name is Chris. So that's going to be the, I think that'll work. And what I'm giving it here is, this is the Bitcoin Cash address that I want to encrypt it for. So it's the person who controls this address is the one who will be able to decrypt it, which is me. This is a WIF, so this is essentially a private key. It's a base 58 format. It's one of the more common formats that you can export a private key into. So if you go to member.cache or memo.cache and you go into your account settings, you can get this WIF, this private key, and it's going to start with either a K or an L, capital K or capital L. That's how you know it's a WIF and the right format of WIF. So, let's see if this works. Yeah, there's too many. So what I want to do is do quotes. Okay, so I'm encrypting it to this Bitcoin Cash address. That's the person who's going to be able to decrypt it. Here's the message. My name is Chris. Here is the WIF that I'm using, the private key that I'm using to essentially pay for the transaction. Oh, okay, so we had an error. So you know what? I hadn't tried with like a string, so I'm just going to really long word. That's what I'm just going to do, a single word for right now, just for the demo. It still doesn't like that. Okay, well, I'll just go back to the one that was working. This is why I'm capturing this, because I don't have any more time to really spend on this today. Invalid checksum. Okay, let me look into this. Okay, that was a problem with the WIF key, with the private key, the WIF. I had cut off these last 3 characters. So let's try this again. So I'm encrypting it to this address. I'm using this private key to pay for the transactions. So normally you wouldn't share this. I've got like, I think 20 cents on this private key. Feel free to take it. And then I'm encoding the message, this is a test. So let's hit enter. And this is by far like the bulk of the code right now. This is the most complicated part, is because not only is it doing this elliptic curve cryptography, it's also taking the encrypted message and splitting it into chunks and then writing each chunk to the blockchain and it's using the memo.cache protocol, but it's also using an extension that member.cache, shout out to FreeTrader there, he expanded on it to do multi-part transactions for large posts. So let's take a look at some of the stuff that came out. Here's the Bitcoin Cash address. Here's the message. Here's the private key we used. It was able to use that get key command and retrieve the public key associated with this Bitcoin Cash address. Here is what the message looks like when it's encrypted, and it's a bit larger because it contains a bunch of like encryption metadata. What I'm doing is I'm generating a serial number. So let's actually click on this link here. Here's where you can see the actual on-chain post at member.cache. So the way this works is I think there's 3 transactions. Yeah, so there's a title transaction which generated this title, and right now I'm doing them sort of an automated or canned title with this like capitalized word encrypted, and then a pound sign, and then a random 8-digit number. So that's what this random 8-digit number right here. And that's just so that, like, if I wanted to build an automated way of going through the blockchain later, which I plan to do, and look for encrypted messages on my address, I can kind of hone in on this, where the word encrypted, capitalized, a space, a pound sign, and then an 8-digit number. So if I find that, my program can know that, like, okay, this is probably the start of an encrypted message, and I can follow the transactions to put this thing back together again. And so this encrypted message here, this is a hexadecimal representation of the binary data, and so this is too big to fit in a single op return. So the program I wrote looked at this. It said, "Oh, this is too big. I'm going to chunk this up." So it split it into 2. So the first transaction was just the title. The second transaction was the first chunk, which contained this much, and then the second transaction was this chunk. And so it sent the first chunk, sent the second chunk, so it resulted in these 3 transactions. So these are all transaction IDs. If you went to like the Bitcoin.com block explorer, you can look those up. In fact, let's just do that right now. This is the title transaction. So if I go to explore.bitcoin.com, I can put that in here, that TXID. And so it's smart enough, it knows that it picked up on the memo protocol, which is the 6002, starts with 60 and then a number, represents the memo protocol. And so this is just the title. So that's just the part that's there, and that's this part right here in the op return. So that's the first transaction, and then I sort of reverse engineered member.cache and how they do their URL scheme. So at the end of it, I provide this URL that you can just click on, and it'll take you to this page. So this is the full encrypted message. Now, the next step is really to have a program just like this one automatically chunked out data and then broadcasted transactions. Ideally, I would be able to reverse that situation, but to make my life easier, I'm leveraging this member.cache user interface. So for the final command, the decrypt command, right here, and again, like, I know it's maybe a little confusing looking at the code, so where you should focus your attention is right here on the GitHub page on the README. I showed the get key command, I just showed the send command, and now I'm going to show this decrypt command. And so the way the decrypt command works, and if you need a hint, you can go bin run help, and bin run help decrypt. So here's the example at the top of the code right here. And like I said, I'm kind of cheating and leveraging the member.cache webpage. So rather than going out to the blockchain, downloading the transactions, and putting the chunks together, I'm just leveraging the member.cache. I'm just going to copy and paste this message here. Now I need to change a few things. This with is the private key for the public key that I encrypted it with. And so I'm going to show that right here. I just took these notes. I created this account on member.cash. It assigned me this Bitcoin Cash address. I converted to Legacy. That's not really important for this. And then I was able to go into the settings and get the private key that starts with the letter K or L. And so I know that this private key is associated with this public address. And this is the one that I sent it to, so that's the right public key that I need. What I'm going to do is delete this message that's in the example, and I'm going to replace it with the encrypted message that we just broadcasted, which is right here. So I'm going to copy and paste that, and so I'm going to decrypt that message. And there we go. This is a test. So it managed to decrypt it. And so here's the WIF. Here's the actual private key in hexadecimal format. And then it decrypted this encrypted message and got the message out of it that we originally started with. Okay, so this is a walkthrough of this prototype that I've put together. So its basic functionality is in place. And I'm going to keep refining this. I'm going to eventually turn this into a Gatsby web app that you can go and just interact with a web page in order to send people encrypted messages. I've also talked with FreeTrader, who put together member.cash, and I've been communicating over Twitter with memo.cash. I think they're both interested in taking this feature and integrating it natively into those sites. And I got to give a big shout out to Vin Armani, because none of this would have been possible without his BFP Encrypt program. This is the same idea, but it uses the Bitcoin file protocol that was developed by James Cramer. And instead of using the Bitcoin file protocol, I'm using this memo.cash protocol. So I reverse engineered his app and pulled out the encryption libraries that he's using, and so I'm just essentially doing the same thing that he's doing, just with a different on-chain protocol. And I think it'll be a little more useful in the context of a social media site like memo.cash and member.cash. Okay, so that's where I'm at, and was stoked to share it with everybody. And like I said, I hope to polish it, but if something happens, if I get sick with coronavirus and die, the code's out there and the video's out there, and hopefully somebody else can pick up the torch if for some reason I can't continue this progress.